Today, Shreya will be playing the Indian wooden flute. Note how she is holding down the same fingers, just changing the way she blows through the flute, and she can play a whole octave higher, from D to D. How is this possible? Well, it's because of waves. But not that kind of wave. The waves I'm talking about are pulses of energy moving through a substance. Waves are everywhere. For example, right now you're hearing my voice as sound waves traveling through air. Let's watch a wave pulse pass through this jump rope. You're probably noticing that there's one restriction to its movement. Since we're holding the jump rope at each end, the wave can't vibrate there. So at those 2 points, the wave must have a height, or an amplitude, of 0. Based on this restriction, we can draw a set of the possible wave diagrams for this jump rope, which are called harmonics. They're called the fundamental, the second harmonic, the third harmonic, the fourth harmonic, and so on. There are a few points on the string where the wave's amplitude equals 0. These are called nodes. And the areas with the maximum amplitude are called antinodes. If the harmonic number doubles, the length of the wave is divided by 2, and the frequency of the wave also doubles, which just means the wave moves up and down at twice the speed. Now, how does this relate to the flute? Well, sound waves pass through the body of the flute just like they pass through the jump rope. The difference is that the flute is an open tube instrument, so the ends are now antinodes, not nodes. So here are the new harmonics. When Shreya plays, even though she's holding down the same fingers, she's actually jumping from the fundamental to the second harmonic. Since the frequency doubles, the pitch that our ears can hear also goes up an octave proportionally. Now, let's check out another wind instrument, the clarinet. Holding down the same keys, the clarinet is actually jumping more than an octave, from D, past D, to A, the fifth above the octave. To find out why the clarinet behaves differently than the flute, let's look at the ends of the tube. The mouthpiece end is closed, a node, and the bell end is open, an antinode. So here are the harmonics, and we see that our second diagram looks a little strange. It should be the second harmonic, but the wavelength is a third of the length of the fundamental, which means that it's actually the third harmonic. For the clarinet and other closed tube instruments, it's not even possible to produce a second harmonic, which is why when Shreya plays, you hear the fundamental and then the third harmonic. The even higher frequency results in an even higher pitch, since we're skipping the octave leap of the second harmonic. Well, that's all for this video. Yes, now you can wave goodbye.